Hey, Mike. Thanks for joining.
Hello.
Hey, still waiting for everybody to trickle in. Thank you, everybody, for joining. Gonna give it a couple more minutes, start at five after. And while we are recording this session, I will disable recording during the question and answer period in case anyone wants to ask questions off record. All right, let's kick things off. Thank you, everybody, for showing up on Friday. This is Building with MuckRock, our monthly session where we go over some different aspect of using MuckRock's tools, technologies, APIs to use in your own projects and products. My name's Alan Lasser. I'm MuckRock's head of product, which means I'm involved with everything from interviewing our users to understand their needs to doing designs and implementing them. So it's a great role where I get to be hands-on and really getting to meet the broad range of folks who use our tools and services. The focus for today's session is enhancing public records work with LLMs. This is a repeat of the session that I and my colleague Sunyan ran at NICAR in March. So if you were there already, this will be familiar to you. And if not, I'm glad that you could catch it on its second pass. I would love to hear any feedback or thoughts you have on this session, or if it ends up leading you to doing any cool things on your own. My email is alan@muckrock.com, and I'll drop that in the chat at the end of the call. So to get started, I wanted to kind of introduce you to the environment we'll be working in today. I'm going to be walking through a Python notebook on my own computer. If you would like to follow along, you are welcome to. However, I found, especially in the last session, it's a little distracting trying to do all the dev setup stuff off the bat. So I'll kind of walk through the steps you can take to run this on your own, but encourage you to run it on your own later. Right now, the notebook that's available has all of the outputs saved, so you can see that as well. So I'm going to start by sharing my screen, and if you want to access any of this code on your own, all you have to do is go to our GitHub repo, which is github.com/muckrock/NICAR. And then inside that repo, we have a folder for this particular session. And in here, we have our README, which is basically an introduction. We have our Python notebook. And then we have the Python files for our dependencies and where we capture some of the output CSVs and data that gets captured by the notebook. So the things we'll cover today is basically how do you take the APIs that MuckRock offers for our public requests, a public records request at muckrock.com, and all of our primary source documents at documentcloud.org. And how do you do more interesting and advanced work with them using an LLM? In this case, I'm going to be showing off working with Anthropic's API and using Claude. But this approach is pretty interchangeable for any LLM that you might want to use. So a few of the things we'll walk through today are how to extract text from documents and analyze their contents and visualize those contents. How you can use MuckRock's API to access our agency database, and how you can file a public records request with nothing more than a few lines of Python. We're going to use Claude to analyze the text that comes out of our documents and some of the PDFs that we get back from Document Cloud. And I really want to use this as a chance to think about how are we applying LLMs to reporting workflows right now. There's still such new novel tools. It's pretty wide open, and there's a lot of cases of both really cool things we can do and pitfalls we might fall into if we're not careful. So today we're going to look at 3 different scenarios that come from MuckRock's community. One is going to be a data set of pardons filed by the Trump administration in its second term. We're also going to look at a folder of police disciplinary records obtained by my colleague Dylan Bergen. And we're going to look at some IG reports that were obtained from a user in the Document Cloud community. If you want to run the notebook by yourself, there's just a few secrets that you'll have to capture in a .env file. And that's going to be your Anthropic API key, which you can get for free, and your MuckRock username and password, which you can also get for free. And if folks have questions about that, happy to answer those at the end. But let's jump over to our Python notebook. You can see it right in GitHub, but I like the presentation a little bit more in VS Code. So that's where I'm going to share from the rest of this time. So here we are, we're in VS Code, we're looking at our Python notebook, and there's a little bit of setup that happens that I'm not going to go into too much detail on. It's detailed here in the notebook, but I do want to talk about the packages we're going to be using. So we're going to be using Python SDKs, which are Python libraries that provide a nice, helpful wrapper over the API of both Document Cloud and MuckRock requests. Once you get comfortable using these Python libraries, it really unlocks a lot of powerful workflows and scripts that you can do that interacts with your own data in either of these services or any public data that's available on these services. We also have the Anthropic library for using Claude from within Python. And then we're going to be using a few helpers. Python.env is going to help us load in our secrets. Pandas is going to help us with working with our data in Python. And matplotlib is going to help us with doing some visualizations. So if you're running this notebook yourself, you want to install those dependencies with vsync. You want to configure your clients. You can see it's pretty straightforward to use either Document Cloud or MuckRock's clients. You simply import it, initialize it. You don't even really need a password or a username if you are working with public data. It's really nice. And we create our Anthropic client with our API key. In this notebook, I've also defined some helper functions that just make it easier and cleaner in the rest of our examples. So you might see some calls to things like save CSV, load CSV to data frame, extract CSV from response. I also made a little helper to send prompts to Claude and abstract some of the headers and other config that you have to do. These are all available in here for reference, but they're not super important. But let's actually get into the meat of this. So my colleague Chris has set up a scraper that basically watches the White House, or I'm not sure which site it is. I think it's the White House site for any presidential pardons. And then anytime a new pardon is issued, it grabs the PDF and it uploads it to a project in Document Cloud. So whenever a document's uploaded to Document Cloud, we immediately run OCR on it if it doesn't already have text embedded in it. In the case of the pardons uploaded by the White House, they are machine-generated PDFs, so they do have some text that's already present in the document. So if we use the Document Cloud library to get the project, we can loop through all the documents in the project and display the text content of those documents. And you can see that here. Very similar format, very similar pattern. The text is pretty clean. It's not perfect, but it's good enough that we can start doing some extraction on it. And there's lots of ways that you can extract text from, find patterns in text. You can use a regex. You can use search. Oh, Sam asked for, can I send a link to the Jupyter notebook? Absolutely. Here you go. Links in the chat. So we could do some there's a lot of ways that we can analyze the plain text that we get back. And we can do, one thing that LLMs unlock is the ability to do semantic search. So rather than searching for a particular keyword, rather than saying, we can say something like, give me all the names of people mentioned in these documents, rather than looking for a particular name. So in this case, I have a prompt that I'm going to send to Claude that combines a request for the name of the pardoned individual, the date of the pardon, the crime they were pardoned for, and I'm asking for it to be returned in CSV format. I combine the text I got from all the documents, and I pass it all along as one big blob of text to Claude. And then here's what I get in response. I get something that, funny enough, uses markdown formatting. So you have to do a little bit, you have to be aware that unless you are really, really particular about how you prompt Claude, it's going to return you markdown almost every time. So in this case, we have a block of uh, CSV data that's formatted inside of Markdown. So we extract that, and then we load it into a pandas data frame. And here's what we get back. We have a list of names, a date of pardon, and a case or a crime associated with that pardon. But how do we know that the data that Claude extracted from the text we gave it is actually accurate? There's a lot of ways we can do that. We can spot check, but one method that I like for working quickly is basically just asking Claude to review its own work. So this next prompt takes our original set of data and the data that Claude returned to us and says, compare these two. Like, are there any discrepancies? Is there anything wrong or incorrect or missing? And we basically tell Claude, take on the role of a meticulous data auditor. LLMs are so funny in that if you basically tell them the role or the persona you want them to maintain, they sometimes return better results that way. It's weird. It's very, very black box. So here we can see Claude ran over it and did find a bunch of discrepancies that could be used to clean up the CSV that it initially returned. And a lot of these have to do with weird text artifacts from the PDFs that we originally passed it. So we see here like the backslash $7 day of January just means like we could read the document and clean that up ourselves. Or we can just default to like, oh, this happened in January 2026. All depends how granular you want to get. But the main point is don't trust everything you get back on the first run. And asking the machine to check its own work is often a good way to quickly identify places that need cleanup. So moving on, with the understanding that these LLMs are not facts producing machines, they are language generation machines. We can't really trust on first glance anything that comes out of them. I really lean away from using generation as a method of analysis. Giving Claude a bunch of documents and asking it to produce a bunch of insights into those documents could easily end up producing fake or erroneous results. So how do we balance that? Like, it's a huge strength that it can just generate text willy-nilly, but also a huge liability. One way that I like to lean into this is to ask Claude for brainstorming or other non-critical idea generation. Especially like asking it to generate ideas and not facts or insights is a responsible way of using this tool. So in this case, this prompt, I'm going to pass it the CSV data that we got back. And instead of asking for insights, I'm just going to ask it for ideas and use it as a brainstorming partner. So given all the data in here in the CSV, what is like a reporting idea that I could pursue on my own? What's a story hook? What's a possible visualization that could be associated with this? And the goal here is not to replace my own thinking or my own experience in identifying stories, but as a way to like speed up my process. So here I'm asking it for 5 ideas. I could ask it for 15, 50. I come from a design background where we often are encouraged as designers to explore the full range of possibilities before honing in on the one we actually want to pursue. So I really like bringing that approach into a reporting process. It's a kind of a rapid prototyping. So in response to this prompt, Claude gave us back 5 story ideas. We can see that within the data set of the pardons, there's information about the first day, of the pardon, you have a lot of stuff related to the 2020 election, uh, old convictions that are being cleared out that could be the start point for a deeper investigation, crypto, um, abortion protesters, and election deniers. So again, like I don't have to write a story about any of these, but they are a starting point. They are a very quick way within a couple of minutes to go from a CSV or a set of documents into a way that I could take action on them. Another thing that generation is really well suited for, you've probably heard about, is like code generation. Claude's really good at writing code, and one of the benefits of code over um, more ambiguous forms of knowledge is that code either works or it doesn't. You either get a result or it fails, and that kind of binary outcome uh, is a reason that we can lean on Claude to generate code, and also trust the code that it outputs within reason. So the next prompt I'm going to give it is I'm going to take one of the visualization ideas that Claude returned from this brainstorming and ask it to write me matplotlib code to generate and prototype out what that visualization could look like. So from the list above, I really liked the idea of the 2020 election and the idea of building a grouped bubble chart, kind of organizing individuals by their role. What are the different people and roles that receive pardons in this data set? And I haven't done a ton of work with matplotlib, so I don't really know how to write it code to generate that kind of visualization. So instead, I'm going to ask Claude to write me some matplotlib code to generate that. And here's what it comes back with. Um, I said I said that you can trust Claude to generate code, and that's generally true, but you really shouldn't execute any code that you get back from Claude without reading through it first. You know, there could be some wonkiness in there. You want to be responsible using this tool. Um, so give it a quick scan. Make sure it's not doing anything funny, like deleting your whole user directory or anything weird. And even though I'm not familiar with matplotlib, I know Python. This looks pretty good. Um, so let's execute it. So here's the line of code that executes the code Claude gave back to us. I keep it commented out in this notebook so that we're not accidentally executing any code if we hit the big run all button at the top. But when I did run this earlier, here's what it came back with. And this isn't the best data visualization. This isn't something that I would publish. But it is, again, a starting point and a way to quickly validate, like, is this an interesting data visualization? Is this something that I might want to try building on my own in a different way? Is this something that I could use as part of a pitch to pursue this story more broadly? And Claude, again, was able to generate kind of from start to finish this whole flow in about 5 minutes. So taking this approach, applying it to all of the brainstorming ideas, you can be very expansive and cover a ton of ground really quickly to hone in on what's the approach you actually want to take. And I think that's really cool and really powerful. And it really means treating Claude as a collaborator and as an aid to your own process and not as a replacement. This isn't saying, great, now we can have Claude do all of our reporting for us. This is saying, like the best kind of computer and digital tools, this is a big enhancement to our own abilities and our own thinking. So the next example I wanted to show is from police disciplinary files. So this is a project where my colleague Dylan requested Brady lists, which is files from district attorney offices, not police agencies. But they point to places where police disciplinary action has happened. And they are a really good starting point for public records requests because they give us the names of officers and the agencies that are in, the police departments that are in, as a starting point for requesting those disciplinary files and seeing if they can get released. So for this example, what I want to do is search the data record that Dylan already pulled together and see if there are some starting points for public records requests that we could file within this data set. So to start, I'm going to load the project that Dylan put together on Document Cloud. I'm going to pick a state to filter these documents by. In this case, Florida. Dylan's tagged all the documents by state, so it gives us a really easy search. And then we can see any documents in that set that come back that were from Florida. And here we can see we got 1, 2, 3, 4 documents with Brady lists and other documents from Florida. And then again, we get the text extracted from these documents from Document Cloud, and we have some plain text that we can start operating on. So in this case, let's see if we can extract the names of police departments that are mentioned in this document set. So I pass it the text that we extracted, I pass it my prompt, and then we spit out the response that Claude gives us. And here we have a nice list of police departments across Florida. So with this list, what we can do is actually cross-reference it with the database of agencies that MuckRock has, which are all agencies that we can send a public records request to using MuckRock's request platform. So we're going to do a search with this list of agencies and just see if we already have them in our system or not. So we have a little bit of code here that checks out the state jurisdiction or the local jurisdiction in Florida. We find these agencies in Florida, and then we output a list of state level agencies or agencies that are in the state of Florida that match the name. And then here's the list we get back from running that request. And we can see there's matches for a bunch of these. And for each one, we have the name of the department, and then we have the reference to the agency in MuckRock's database. So in this example, I'm going to focus on the Homestead Police Department, agency 20102, a very nice palindrome that I only just recognized. So let's go back to our set of documents and find where Homestead is mentioned in any of them. So we'll use the Document Cloud API to, again, search for any records in mentioning the Homestead Police Department. And what we get back is text that includes some names, some statuses. One thing that the Document Cloud API is really good at is just returning the highlights of, if we use the mentions true flag, the search just returns like, here's places in these documents where the search query is mentioned. So it's a nice way of getting blocks of text rather than the text of the whole document. And with the names of these officers, we can now start to pull together a public records request for records mentioning them. So doing a manual scan through this, I was able to pull out a few different names. And then I was able to use it to compose a very simple records request that mentions them specifically by name, is sent to the police department they're associated with, and is requesting records like their personnel files, disciplinary records, or any other records referencing officers or their connection to not being able to testify on a witness stand. And with that, we basically have our request that's ready to send. We find our organization in MuckRock that we want to submit the request through to use the request credits associated with my newsroom. In this case, I'm a member of MuckRock staff, which has an ID of 1. The first organization ever in MuckRock system was our own, which is funny and great. And then if I uncomment these lines here and run this block of code, I can create a new public records request that's sent to that agency. I'm not going to do that here, but you can see these are the building blocks of scripts you could use yourself to do kind of programmatic and large scale analysis. You could run through a much larger data set. You could be broader in your scope. I just focused on one police agency, but you saw how many matches there were there. Um, and it's really cool thinking about the ways that you can apply the kind of scale that scripting and this kind of approach to data journalism unlocks for doing a much larger project, within your state or within your county. And then all the records that are returned through any of these requests can be contributed back into Dylan's project. Keep building that public repository of information that we've been gathering over years. The last project I want to talk about is by Chris Keller, who's at the Associated Press. Chris keeps an archive of Inspector General reports that can provide us with some interesting ideas into other public records requests we might want to duplicate or even understand the success or failure records of certain kinds of requests. So we can get FOIA logs out of some of the OIG documents and use that again as a starting point for some reporting. So in this case, I'm going to use Chris's project ID to get the IG reports, and then I'm going to search for any documents in this project that have log somewhere in their title. And what comes back are some FOIA log documents. So OIG FOIA log, another OIG FOIA log. Great, this is enough that we can start working with. Another really cool thing you can do with Claude, rather than trying to get the text content of these records, we can just pass Claude an entire set of PDF files, and it can read through them on its own. Alex, who's currently here on this call at his NICAR session, did some other really cool things with like Claude's ability to do image recognition versus text recognition. So rather than passing just that prompt with our extracted text, in this case, we're going to take the PDFs, convert them into a base64 format, and then include them along with our prompt, basically including them as attachments. And then in our prompt, what we're going to say or ask Claude for is, please output a CSV file that extracts any tables that are present in these documents. So these FOIA log documents often have kind of printouts or visual representations of tables that we can turn into data. You could use a tool like Tabula for this, but within the scope of this, like LLMs are another pretty valid approach to doing a similar data extraction. So running our prompt, we get back and load into our data frame the tables that are present in the documents. So we can see the date they were received, the year they were received in, the disposition, how it was resolved, and if it was denied, the reason for the denial. And just with this table and this set of data, we can do some analysis on it. We could try doing a visualization. So let's start by just kind of charting the breakdown of like, how are these different requests resolved? So this code here is going to basically catalog the disposition, group it into buckets, and then we'll take that these buckets of status counts and use matplotlib to turn them into a pie chart. And here's the pie chart we get back. We can see that of all the requests in the logs we extracted, 40% had a partial grant, 30% had no status associated with them, 6.8% were total denials. So this gives us a pretty quick sense of like, what's the content of this entire data set in a really easy to understand and grasp way, versus reading through the entire table. Um, and again, with using generation and leaning on the strengths of the LLM, I'm going to pass Claude this table we got back and ask it to help me identify requests that might be good for me to duplicate. We can give it a set of criteria to consider. In this case, we only want to duplicate requests that were granted in full or in part. We want to avoid any requests that are for personal information or are really specific to an individual, um, along with a few other qualities here. And then in the output, basically ask for it like, why is this worth duplicating? What's a potential angle I could use? I don't have to use all of its recommendations, but this is a way of quickly filtering down that table of how many records were in this. So going from 103 rows to 8 or 9 ideas for requests in a matter of minutes. And here's the table that I returned back. So we can see detainee death records, very topical, and because we filtered by partial or full response, we know that like these records exist. That might be worth duplicating. Similar for the rest of the responses in here. This is in the notebook if you want to explore it more in detail. But the basic, you know, the takeaway here is we went from a project with a set of PDF files to a set of public records request ideas, again, in a matter of minutes. This is an accelerant to a reporting process. This isn't a substitute for it. And it's a way to quickly get a sense of the landscape and without having to spend hours reading through each document individually. This is using computers, for what they're best at, rather than trying to make them impersonate somebody, which is not what they're best at. And the thing that I'm really excited about is that MuckRock has offered these tools, these Python libraries, these APIs for years, over a decade at this point. And they've had a really high learning curve. They've been really powerful, but that power hasn't always been super accessible. And with LLMs, one of the great things is it makes a lot of these technical systems much more legible to ordinary folks and much easier to work with. We're still exploring other ways that we can use these tools responsibly to enhance reporting flows and make all of our tools and all the power they contain easier to unlock for reporters like you. Thank you for following along and happy to open the floor to questions or a wider ranging discussion on this. Feel free to unmute or unmute your audio or your video. And let's see, it's 1:40 now. I'll give us about 5 to 10 minutes of discussion time within the call recording that we have going. And then I'll turn the recording off in case there's anything we want to talk about with a little more privacy. But thank you. Oh, and I did say that I would drop my email in. You can see it here, and I'll put it in the chat as well. Let's see. Mike asked, could you recommend books on LLMs or learning Python? That is a great question. I don't know of any books on LLMs that I would recommend, especially that it is such a fast-moving space. I don't know that LLM that a book might be the best source for building skills with LLMs right now. I would definitely recommend for that um, either online tutorials, things like YouTube, or especially Simon Willison, who is a collaborator with Alex Garcia, has a great blog where he's really doing a lot of he's following along with the ways that the industry is growing and changing, and he has a data journalism background, so he has a nice point of view on it. Yes, and Alex just dropped the link in the chat. For learning Python, I would actually recommend. I can't remember the exact name of this book. You'll have to give me a second. Okay, yeah, it's Automate the Boring Stuff with Python. I think, especially for someone who doesn't have a ton of programming experience, this is a really great, like, very beginner friendly book that I think really does a good job of expressing the mindset of working with Python rather than being particular about here's how you do this or that. It's more like when is the right way to apply this to solving a problem. And I definitely feel like automate the boring stuff is something that LLMs are pretty good at as well. So that might be a good spot to get started. Yeah. Anybody else have any questions? Well, if not, I think I'll leave it here. Again, please reach out to me if you got any thoughts or any strong takeaways from this, or anything you want to show off, or any questions about using the different APIs and tools that we make available. Um, and again, thank you everybody for attending. Hope you have a great Friday.